Okay, in this video we will solve this system using the elimination method. As I work this problem out, I'll be performing calculations, but I will not be showing you those calculations. For example, if I had to do 3 times -7, I'm not going to show you what I do there. I'm just gonna do it. So make sure that you have a calculator, that you're following along, and you can pause this video at any time. So we have the system of 3 equations with 3 variables. 2x plus 3y plus 7z equals 13 is equation 1. 3x plus 2y minus 5z equals negative 22. And 5x plus 7y minus 3z equals negative 28. So we're going to use the elimination method. And what we will be doing, so you kind of want to set out a plan ahead of time. And what we'll be doing is we'll be eliminating the x term in equation 2 by using equation 1 and in equation 2. Then we will be eliminating the x term in equation 3 by using equation 1 and equation 3. Notice I said we're going to use equation 1 both times. And notice I said both times we'll be eliminating the x term. That's what you want to do. You want to use one equation twice. Okay, so let's set up equation 1 and equation 2. There's equation 1. There's equation 2. Okay, like I said, ideally, the one equation that you would use both times, if you have an x by itself, that's the equation you want to use. Okay, so I don't have that. So what I need to do is I need to multiply both equations by some number. It looks like I want to get -6 and +6. So I'll multiply this equation by -3 and then this equation by 2. So as a result of doing that, I get -6x minus 9y minus 21z equals -39. I distributed the -3 to each term. Now distributing the 2 to each term, 6x plus 4y minus 10z equals -44. Now we add these two equations together. The x terms eliminate. Adding the y column, we get -5y. Adding the z column, we get -31z. And adding the constant column, we get -83. Okay, hold on to that equation. We're going to use that a little bit later. Let's go back up to the original system. So now I want to use 2x plus 3y plus 7z equals 13. And equation 3, 5x plus 7y minus 3z equals -28. Okay, let's set that up to be eliminated. So we'll set up with equation 1, 2x plus 3y plus 7z equals 13. Equation 3, 5x plus 7y minus 3z equals -28. I want to eliminate the x's, so I'm going to have to multiply both equations by a non-zero constant. Looks like I want to get -10 and 10, so I'll multiply our equation 1 by -5 and the other equation by 2. As a result, we get -10x minus 15y minus 35z equals -65. And as a result of the second equation, 10x plus 14y minus 6z equals -56. I will add these two equations together. The x's again cancel. Adding the y column, -1y. Adding the z column, -41z equals, adding the constants, -121. Now I have two equations with only 2 variables. I'm going to use those 2 equations now and set up a new system. and eliminate one of those variables. So I'm going to write them down over here. And I'll work on this system right now. Okay, it looks like I can multiply equation 2 here by negative 5. That'll give me a positive 5y to eliminate with the negative 5y. So I'm just going to copy the first equation over because I'm not multiplying it by anything. And now I'll distribute the negative 5 in the second equation. And as a result, I get 5y plus 205z equals 605. Add these together, the y's cancel, and we get 174z equals 522. Solve this for z, and we get z equals 3. Good. Now what we do is we take one of those two equations with two variables, and we substitute z in order to solve for y. So I'm going to use the equation negative 1y minus 41z equals negative 121. This process right now is called back substitution because we are substituting our answers backwards. For example, we just found out that z equals 3. Now I'm going to substitute z into this equation, which contains two variables, in order to solve for y. So I just put 3 in for z. Now I get negative 1y minus 123 equals negative 121. I will add 123 to both sides. I get negative 1y equals 2. Therefore, y equals negative 2 by dividing both sides by negative 1. Now I know what z and y are. So I'm going to take that very first equation that I used both times, which is the 2x plus 3y plus 7z equals 13, and I'll substitute my known value for z and my known value for y in order to solve for x. At this point, you could actually use any of those equations up top. So let's substitute 2x plus 3 times negative 2 plus 7 times 3 equals 13. Remember, y equals negative 2 and z equals 3. So we're just substituting those in to this equation. 2x minus 6 plus 21 equals 13. Grouping like terms, 2x plus 15 equals 13. Subtract 15 from both sides, 2x equals negative 2. Divide both sides by 2, x equals negative 1. Therefore, our solution is the ordered triplet. Now remember, this goes in order x, comma, y, comma, z. Negative 1, comma, negative 2, comma, 3. You can check this by substituting each x, y, and z into each of those three equations and make sure or verify that it's true for each of the three original equations, which it would check. Okay, in this video we're going to be solving this system by using matrices. Now we're only going to go as far as writing the system in row echelon form. So just to remind you what row echelon form looks like, it is a matrix, an augmented matrix, in which the diagonals are all ones. Now I'm just using letters A, B, C, D, E, and F to indicate real numbers. They could represent any numbers. But the diagonals must be all ones. And then from this, we're going to be able to come up with a new system of equations which is equivalent to the original system, and we'll be able to back substitute. Okay, so that's the goal, is row echelon form. Notice where the zeros are. The zeros are in this corner right here. Okay, so we need to make zeros right here. So we need zeros, which means we need to eliminate. Okay, I'm going to erase what I just drew right there. But that's where those are the ones we need to eliminate. So I just used the word eliminate, and the matrix method is really the elimination method. Okay, so I'm first going to write the augmented matrix. And what we do is we just write the coefficients. I'm going to put my line in a minute as soon as I get done writing all these coefficients. Notice the first column are the coefficients of x. The second column are the coefficients of y. And the third column are the coefficients of z. And then the last column on the other side of that line that I drew are the constants on the other side. Okay, so the order I like to do this in is to first try to get a 0 here. Second, try to get a 0 here. Third, try to get a 0 here. So you do it in that order. Okay, now I'm going to keep writing this matrix over and over and over and over and over again. Alright, so I need to make that 2 a 0. So I'm going to use rows 1 and rows 2. So I'll show you my work's going to be done over here. Row 1 is 3, 2, negative 3, negative 2. Row 2 is 2, negative 5, 2, negative 2. Alright, it is not possible. Well, let me backtrack. If you can get a leading coefficient, an x coefficient of 1, you should put that row immediately to the top. We don't have that luxury, so we're not going to be able to do that. You could actually divide that first row by 3s across the board, but then you're working with a lot of fractions. So I'm actually going to change that initial 3 in that top left-hand corner. I'm going to change that to a 1 at the very end. It's a little different than the standard way of doing this, but it works a little bit easier, I believe. So I need 6 and negative 6. So I'm going to get the negative 6 there and the positive 6 here. So I'm multiplying these. It's just like the elimination method, except you don't use any of the variables. So I'm going to distribute this negative 2. And as a result, I get negative 6, negative 4, 6, 4. Now I'm going to distribute this 3. And as a result, I get positive 6, negative 15, positive 6, negative 6. I'm going to add these together. And as a result, I get 0, negative 19, 12, negative 2. Alright. I'm going to replace row 2 in my matrix with this result. So when I rewrite the matrix, just write the first row in the original format. Now write the second row in your new format. You didn't do anything with the third row, so keep that the way it is. Draw your line and draw that. Okay, now we have a new challenge ahead of us. Let me just fix this. Alright, great. Okay, now I want to use the first row, 3, 2, negative 3, negative 2, and row 3, 4, negative 3, 4, 10. And I want a 0 where the 4 is. Okay, so what I'm going to do is I have to multiply both of these. I'm going to multiply this first one by negative 4 and the second one by 3. Now as a result, I get negative 12, negative 8, positive 12, positive 8. I just distributed the negative 4. Now I'm going to distribute the 3, and I get, as a result, 12, negative 9, 12, 30. Add these together. 0, negative 17, 24, 38. So when I do this, I'm just adding each column. Now I'm going to replace row 3 with that result. So keep row 1 the way it is. Keep row 2 the way it is. Now replace row 3 with the result you just obtained. Put your line in, close it. Okay, we're looking good so far. Now we need to get rid of that negative 17. We need a 0 in that location. Okay, some people will tell you that you should now divide each entry in row 2 by negative 19 to get a resulting 1 there. The way I do it eliminates the use of fractions. I don't know if you'd appreciate that or not, but I know that I don't really like to work with fractions, so it eliminates that result. Now we're going to use rows 2 and 3. So I'm going to copy down rows 2 and 3. 0, negative 19, 12, negative 2. That's row 2. Now row 3. 0, negative 17, 24, and 38. Okay, we're going to end up with some big numbers here, but that's okay. I need to eliminate that negative 17. So I need a 0 there. That means I need opposite coefficients. I currently have a negative 19 and a negative 17 in that second column. 19 and 17 are both prime numbers. So I'm going to multiply the first row that I have by positive 17. Then I'm going to multiply the next one by negative 19. Okay. A positive 17 times the negative 19 will result in a negative value. The negative 19 times the negative 17 will result in a positive value. So just watch what happens here. 17 times 0, 0. Now that's the beauty of getting rid of those x coefficients first and getting 2 zeros in that first column, because now no matter what you multiply, it's going to be a 0. So that will remain 0, which is really nice. 17 times negative 19 is negative 323. 17 times 12, 204. 17 times negative 2, negative 34. Negative 19 times 0, 0. So now I'm working on the second equation. Negative 19 times negative 17, positive 323. See, those will go away. Negative 19 times 24, negative 456. Negative 19 times 38, negative 722. Okay, I did not do those in my head. I did those with a calculator earlier on. So you can pause and verify that those calculations are correct. Use a calculator to help you work this out. Okay, add these two together. First column, 0. Second column, 0. Next column, negative 252. Last column, negative 756 when you add those columns. Alright, right now, it would be ideal to divide each of these terms by negative 252. just to simplify. We're going to see if we can get a 1 where that negative 252 is right now. Okay, this results in 0, 0, 1, and negative 756 divided by negative 252 is 3. All right, that's what we're going to replace row 3 with. So here's where we were, in the upper left-hand corner of your screen. Rows 1 and 2 will stay the same. Row 3 is going to get replaced with what we just found. Okay. So rewriting our matrix, row 1 stays 3, 2, negative 3, negative 2. Row 2 remains 0, negative 19, 12, negative 2. And row 3 now becomes 0, 0, 1, 3. Now, if you are not worried about obtaining row echelon form, you are ready to back substitute right now. Okay, but we want to get row echelon form. So I'm going to do all these within this matrix here. Row 2, I'm going to divide each of those by negative 19. Row 1, I'm going to divide each of those by 3. The result is 1, 2/3, negative 1, negative 2/3. 0, 1, negative 12/19, 2/19. 0, 0, 1, 3. This is row echelon form. Okay, now we need to back substitute. So from this, we get a system of equations that says x plus 2/3 y minus z equals negative 2/3. Y minus 12/19 z equals 2/19. And z equals 3. Okay, now we know z equals 3. So we're going to substitute 3 in the equation right above it. And we get y minus 36 over 19 equal to 2 over 19. We will add 36 over 19 to both sides, and we get 38 over 19. We'll simplify, and we get y equals 2. We will now copy down the equation with 3 variables, which was x plus 2/3 y minus z equals negative 2/3. And we will substitute our answers for x and y. So x plus 2/3 times 2 minus 3 equals negative 2/3. X plus 4/3 minus 3 equals negative 2/3. Multiplying this whole equation by 3, we get 3x plus 4 minus 9 equals negative 2. Simplifying, 3x minus 5 equals negative 2. 3x equals 3. X equals 1. So the solution is 1, 2, 3. X is 1, y is 2,